Negative feedback. Negative feedback is the most common way that homeostasis works. It's basically the ability to stabilize or keep yourself balanced, if you remember. There's a couple of steps that are involved in this to keep you balanced. Anything out of balance is going to keep you imbalanced. And when I mean balance, I'm not talking about when you walk. I'm talking about keeping you in a narrow temperature range or pH range or oxygen range. That's what this is processed. So number one, there's a stimulus that produces a change in the variability. Let's keep with heat because we've kind of done that one already. A receptor detects the change in your neurons. The input is that you are hotter, and that's going to now go to a control center, which is your brain. So that first part, that one that detected any change, is called the afferent pathway. It's just basically noticing that something happened and sending a message to the control center. The afferent pathway is the effector one. So now there's going to be an output, and the output in our example is there's going to be a message sent to the skin. The skin is going to then produce water, which is sweat, that is going to be sort of evaporated around us, and that's going to cool us down. So the response of the efferent is to make sure that we get back into balance and return to homeostasis levels. Once we do, then that stimulation that was occurring in the beginning stops, and we go back into that normal balance until we're imbalanced again, and we'll continue this. So one type of balance, and please don't think this is the only homeostatic pathway, there's tons, would be thermoregulation. If temperature is high, you sweat, and that's done through this thing called vasodilation of the blood vessels, and that increases the loss of heat. So vasodilation is basically your blood vessels start to move faster, and it's going to radiate heat. That's one of the things that you do. And that's also going to create sweat. You're doing it almost like a radiator in your body, in your car. Basically what happens is by making hot stuff go past the radiator faster, it's going to cool the car down faster. Now let's look at the opposite. If temperature is low, shivering begins to produce in the heat, and that's going to be vasoconstriction. Well, that's going to make those blood vessels near the surface of the skin dilate, so it's constricted, because you don't want them exposed to the outside environment. Because it's cold, you want to bring them in a little bit and make it so the cold environment doesn't affect them as much. So it's going to decrease the loss of heat. And then also, of course, you're going to go ahead and start to shiver and things like that. Negative feedback with thermoregulations. If we think about, remember that afferent and efferent responses? We talked about a couple already with the afferent one. We talked about heat. So it's going to be the hot one. Body temperature rises, skin temperature, cells in the skin and the brain are the ones that are going to be in the receptors. Those are going to be the afferent one. The control center is going to be the brain, and it's going to turn on the thermoregulator. It's going to affect sweat glands, and that evaporation that occurs around you when you sweat is going to bring your body temperature down. Let's look at it the other way now. Now it's too cold. So the receptors in your skin are also part of the afferent pathway. They're going to go to your brain and say, hey, it's too cold. The afferent or effect is going to occur is that your skeletal muscles are going to start to move around a lot more, and that's going to create the process of shivering. They're basically burning a lot more sugar to basically keep you hotter, and by shaking it's going to need energy, and that's where that sugar comes into play, and that's going to bring you back down into your normal temperature. These two methods of, we talked about negative feedback. That's going to be the majority of methods that homeostasis works. But there are a few, very few methods that use this thing called positive feedback. So a normal way of producing a rapid change is going to be a positive feedback. And basically it's going to be a change that leads to an even greater change in a certain direction. And it'll make sense in a second. Positive feedback is going to be triggered by a couple of things that we're going to talk about: blood loss and even producing milk and some other homeostatic reactions. So in my example here, positive feedback is triggered by some damage to a blood vessel. So you got cut. The damaged tissue sends out a chemical to the body to recruit these platelets. Platelets are basically these little cells that will plug up the hole to make it so you don't leak out. More chemicals get attracted by this process, so that one feedback starts to make more and more and more chemicals come to this one area, and they're all going to basically help plug that blood vessel. So initially the blood vessel is leaky. You're going to create this like clot with these platelets. Eventually that platelets are going to plug the hole, and then more chemicals will come to eventually heal that wound. The next video will be on macromolecules and what those are.